Hello everyone, welcome to the session. In this session, we'll try to solve few problems which are asked in GATE and ESE. Now we'll start with ESE problem which is held in 2020. And the first one is when the pressure of liquid is increased from 3 meganewton per meter square to 6 meganewton per meter square. That means the pressure is increasing from 3 to 6. Okay, it is increasing. Okay, and its volume is decreased by 0.1%. Just concentrate on this, decreased by 0.1%. And the bulk modulus of elasticity of the fluid or liquid will be. And first, when you're solving any problem in any competitive exam, try to understand the problem first, and later try to understand what they're asking to find. Here in this problem, here they are asking to find bulk modulus of elasticity of the liquid. So according to the properties of fluids, we have the bulk modulus of elasticity, which is K is equals to dP, which is change in pressure divided by change in volume by volume, which is a negative one, right? This will be decreasing in your volumetric strain. So now bulk modulus of elasticity is change in pressure to the volumetric strain. So in this, first we'll see what is change in pressure. That is, it is increasing from 3 to 6. So change in pressure is P2 minus P1 and divided by what is change in volume, which is like V2 minus V1 divided by V1, right, which is the original one, final minus the original volume, and here the original volume. And now P2 minus P1, which is what is the final pressure, 6 minus what is initial pressure, which is 3, divided by, and here it is very important, just concentrate on this, which is decreased by 0.1%. What is decreased by? So decreased by 0.1% means it is 0.1 divided by 100. Is it right? 0.1% means, so in 100% of volume it is reduced or decreased by 0.1. okay, the value of 0.1. that means we can write like 100 minus 99.9 divided by 100. Here what is the original volume? 100. What is the final volume? 99.9. that means the volume is decreased by 0.1%, right? It is 0.1 is decreased in this value, like 100 minus 99.9 is equals to 0.1. that means 0.1 part is decreased in the volume. So now what is the final volume here? 99.9. so if you substitute here, this is your final volume and this is your initial volume, and the final volume is 99.9 minus initial volume is 100 divided by 100, which is initial volume V1. And now what happens if you subtract 99.1 minus 100? You will get a negative value, which is like minus 0.1 divided by 100, and here what you're going to get is 3, and this negative value and this negative value will get cancels. So finally what you're going to get is 3. Here the mega newtons value is there, so instead of mega you're going to take newton per meter square. It is 10 to the power of 6 divided by, what's your value of this? 0.001. so instead of writing like this, you can simply write 3 into 10 to the power of 6 divided by 1 into 10 to the power of minus 3. That means I am just taking all these 0 to the outside. So what I'm going to get is 10 to the power of minus 3. And if you simplify this, what you're going to get is 3 into 10 to the power of 9 Newton per meter square. You can see the answer here. It is big. 3 into 10 to the power of 9 Newton per meter square. And the issue is here it is decreased by 0.1%. What happens if the problem is changed to decrease it to 0.1%? What happens then? We'll see. Decrease it to 0.1%, then what happens? From 100, your final value is 0.1 divided by 100. So what's your value now? Just make 900 minus 0.1. What you're going to get? 9.99 divided by 100. See, this is your total volume that is decreased. That means you're going to get 99.9%. But here, what you have here is decreased by 0.1%. So that's why your volumetric strain, what you got here is 0.1 divided by 100. Okay, that's the difference between your by and the two. Don't confuse with these two. These just small words will change the total scenario of your problem. Clear? We'll see the next one. And this is your gate problem, which is asked in mechanical 2019 in set 1, which is 2 marks. You can see here, two immiscible incompressible. Immiscible means it won't mix together. Incompressible means when they are touching each other or contacting each other, it won't compresses. And these are viscous fluids. That means the shear will exit having the same densities but different viscosities. Viscous will be there for the two fluids. See, here you can see this is one fluid and this is another fluid. But the thing is, the viscosities will be different. What's that viscosities? It's already given in the figure, which is like viscosity of your second fluid is 2 times of the viscosity of first fluid. So which are contained between two infinite horizontal plates, and these fluids are contained in a horizontal parallel plates which are 2 meters apart as shown in the figure. The bottom plate is fixed and the upper plate moves to a right with a constant velocity of 3 meters per second. So you have to observe this. Here the velocity is constant. Okay. And now what he's saying is the lower part of your plate is constant. So there your velocity is equals to 0. The upper plate, the velocity is constant, which is 3 meters per second. And with the assumptions of Newtonian fluids, study and fully developed laminar flow with zero pressure gradients in all directions, the momentum equation simplifies to okay. And if the dynamic viscosity of the lower fluid mu2 is twice that of upper fluid, which is u1, which we already seen in the figure, then the velocity at the interface, so he required the velocity at the interface. He required the velocity at this particular point, which is, assume that this is just v. Okay, round off to 2 decimals. Okay, round off to 2 decimals. Here we don't have any options. It is a bit okay. You won't get any negative marks, but if your answer is right, then you're going to get the mark. But if your answer is wrong, you won't get any negative marks because there is no options for this. Okay, without options, we'll try to solve this. So finally, once again, when you're trying to solve your problem, try to understand what they given, and the first step is to understand the problem, and the second step is you have to know what they asked to find. Here they asked to find the velocity at the interface. Okay, first try to ask yourself what is the shear stress at this particular point. And now we'll try to solve the problem. So as per the given problem, here we have a plate, and this is your fixed plate, which where with the velocity is equals to 0, and this is your upper plate which is moving with a constant velocity like 3 meters per second, and what we require is a velocity at the interface, and what is your shear stress at this interface is, so the shear stress is tau 1 is equals to tau 2. That means this is fluid 1 and this is fluid 2, and your shear stresses at the interface is equal. That means shear at 1 is equals to shear at 2, and we require the velocity at this particular interface, which is v. You are considering it as v. And what is the shear stress formula as per Newtonian fluids? It is like mu 1, which is mu 1 of your first fluid, mu of first fluid, and what is change in velocity, which is like you will get some change in velocity divided by height 1, and that equals to mu 2 change in velocity divided by height 2, that is your y direction, height in y direction. And what is u1? It is just u1. And what is your change in velocity in fluid 1? It is final velocity is 3, the initial velocity is v. Just assuming that here the velocity is 3 and here the velocity is v, what we required to find, right? And divided by what is the height here, height of this particular, it's already given in the figure. You can see the total height is 2. The total height is 2, which is like 1 meter, and this is 1 meter, and now it is 1, and that equals to your mu 2. What is your mu 2 value? It is 2 times of your mu 1. 2 times of your mu 1. And what is change in velocity in this particular fluid? And that is v minus 0. That is, it is changing from v to 0, divided by what is the height? Again it is 1. And if you cancel these mu 1s and 1 here in the denominators, what you're going to get is 3 minus v, that equals to v minus 0. Sorry, here it is like 2v, 2 is left, and finally what you're going to get is 3 is equals to 3v, and v equals to 1 meter per second is your answer. Okay, so he's asking to round off to 2 decimals, but your answer is still 1. You can simply keep as 1 meter per second. You can see the answer, which is 1 meter per second. We will continue in the next session. Thank you.